Hello guys, welcome to another lesson on Introduction to Ordinary Differential Equation. Today we are looking at verifying solutions to differential equations. And then what we mean about this is that a particular function will be given to us, then we will try to verify whether that function is a solution to a given differential equation. That is, when we substitute the various parameters needed over there into that particular differential equation, it satisfies that differential equation identically. That's what we are going to look at. So without wasting time, let's start. So it says verify whether the given function is a solution to a stated differential equation. So our first problem is y equals cos x, to verify whether this is a solution to this. So let's solve it. Make sure you subscribe to the channel. Please try and share to others, and then comment. Our first example, we are given this. So all that we are going to achieve is that we are going to substitute what we have here into this, but we can see clearly that over here we have the y, but we don't have the y prime prime. So we need to differentiate this function to find the second order, and we put everything into it. If we get what we have at the other side of the equation, hence it satisfies it all, it is a solution to the differential equation. So we have y equals cos x. So our first derivative will give us negative sine of x. Then our second derivative will give us a negative, and then the differential of sine x is cosine of x. Now we have the y over here. Let's label it as 1. Then we have our y prime prime here. Let's label it as our 2. At this stage, let's take the left hand side. It's y prime prime plus y. So let's do the substitution. Our y prime prime is cosine x, negative cosine x. Then our y is cosine x. And clearly, you can see that we are going to get negative positive, so that will be what? 0. So we conclude that therefore, since the left hand side is the same as the right hand side, hence y equals cos x is a solution to the differential equation. Now our second example, it says we should verify that y equals e power sine x is a solution to y prime prime minus y cos x plus y sine x equals 0. So let's look at that one too. Our solution. So as usual, let's take the function this. When you see from the differential equation that we need to get our second derivative, then our first derivative, and our dependent variable. Already the dependent variable, we have it. So we need to get this and this. So our first derivative is, we first of all need to maintain the function times the length of the base, so we're going to get length e, then times differential of the function within function, that is the exponent here, and that is what? Cosine of x. Now we should know that our length e will give us 1. So if length e is 1, then it means our y prime now becomes cos x e power sine x. So that's what we have. Then we need to go further to differentiate that one to get our second derivative or second order. And this is a product. So if it's product, we learn that we need to maintain one of the parameters, then differentiate the other. So we are maintaining this and to differentiate this. And this we differentiated, and we had the same thing over here. So that will be cosine of e power sine x. We are not done. Plus, now we are going to maintain this and differentiate this. So let's write that one first. Then the differential of cos x is what? Negative sine of x. So let's simplify. So our y prime prime is going to be this, and this will give us cosine squared x e power sine x minus sine x e power sine x. So now we have all the parameters to substitute. So let's label them. So this is what we are going to substitute into the left hand side of the differential equation. So taking the left hand side, y prime prime, we had cosine square x e power sine x minus sine x e power sine x. So that's for the y prime prime. Then we have this minus here, minus the y prime. The y prime, we had cosine x e power sine x. Then we have the y prime times cosine x, this cosine x. Then plus our y. Our y was given as e power sine x. Then that multiplies sine x. So now let's simplify. So we have cosine square x e power sine x minus sine x e power sine x. So here this multiplies this, we're going to get minus cosine square x e power sine x. Then this by that will give us plus sine x e power sine x. So that's what we have. So let's group the like terms. We have cosine square x e power sine x, and this is the same thing, minus cosine square x e power sine x. Then this minus sine x e power sine x plus sine x e power sine x. So you can see clearly that this get rid of this, and then this get rid of this, which gives us what? 0. So we can conclude that therefore the left hand side is equal to right hand side. Hence y equals e power sine x is a solution to the differential equation. Our next problem here is to verify that y at x equals c e power minus x squared. So this is what we are given. So let's look at that one too. So we have y at x equals c e power negative x squared. Remember, this x over here simply means a function y with respect to x, so we can ignore it. So let's find our first derivative. And first derivative, we know that we have the constant, so let's put the constant out. Then differentiate what we have here. This is exponential function, so you know the process. Maintain the function times length of the base times the differential of the function within function, and that will give us negative 2x. Simplify. In simplifying, we are going to get negative 2xc e power negative x squared. So that's our y prime that we need to find. This is our equation 1, equation 2. Let's substitute. Taking the left hand side, we have y prime plus 2xy equals, to our y prime we had negative 2x c e power negative x squared. Then our plus 2 x, the y, c e power negative x squared. And obviously this negative is positive, cancels out, and that will give us 0. Since the left hand side is equal to right hand side, the function y equals c e power negative x squared is a solution. So that's that. So we're given y equals half x e power x plus c on x e power x. So let's find our first derivative, and our first derivative will be, this is acting as a product, so let's take the constant out. Then over here, let's maintain the first function, then differentiate the second function. You know, whenever we differentiate e power x, we get the same thing. That's e power x plus, now let's maintain this and differentiate the x. That's to give us 1 times, that is the same thing, and close, plus over here too, this is a constant on x, so let's factor the c out. Then we are going to get 1 on x, so let's maintain that 1 on x, then differentiate this, and that will give us the same thing, plus, now let's maintain this and differentiate to the 1 on x. You know, whenever we differentiate 1 on x, we're going to get negative 1 on x squared. Then we maintain this, so that will give us, let's write it well. Let's simplify. So simplifying this, we're going to get half x e power x plus half e power x plus c on x e power x minus c on x squared e power x. So this is what we have. You can see clearly that we don't have anything in common, so that will be our next equation. But we just have to find the first derivative, so that's what we have. Let's substitute that into this. So taking the left hand side, so our left hand side was x y prime plus 1 minus x y. So let's substitute. So our x will be here, then our y prime is the whole of this, and that'll be 1 on 2x e power x plus half e power x plus c on x e power x minus c on x squared e power x. Close it. Then plus this, plus we have, it's not good, so let's come down. We have bracket 1 on x, and that multiplies the y. The y was also half x e power x plus c on x e power x. And let's close that. Let's continue. Let's expand. So expanding, this multiplies through, we are going to get half, this will give us x squared e power x. Then this by that will also give us plus half x e power x. This by that will give us plus, so when multiply there, this will cancel that. So we are going to get c e power x. Then this by that, we are going to minus c on x, because one of these will cancel this, e power x. Then now this need to expand. So expanding, the 1 multiplied through everything, so 1 by that will give us plus 1 on 2x e power x, and 1 by that again plus c on x e power x. So now let's take the negative x to multiply to minus minus half x squared e power x minus c e power x, because this x here will cancel this, so you like this. Let's check it out and see what we've gotten. So it's clear that half x squared e power x is the same thing as this, and half x squared e power x, this negative is affecting, so that is gone. Then our half x e power x is the same thing as half x e power x. So we can put that together. Half plus half was 1. And so that will give us x e power x. Now our c e power x is the same as negative c e power x here. So that also is off. And finally, our negative c on x e power x is the same as the positive over here. So this positive is negative. So go. Hence, we have gotten the left hand side. That's what we have here. So therefore, the function is a solution. Our last example was to verify or show that this over here is a solution to this. Actually, this is the differential equation because we have the derivative in there, and there's a function. So let's look at how it's solved. A solution. In this problem, this is our differential equation. So let's try to write it well. We are going to have 3y dx equals 2x dy. So let's divide by the dx, and that's we're going to get 3y equals 2 dy dx. Let's make dy dx the subject, and that will give us 3y on 2x. Let's label that as our first equation. Over here, now in this problem, let's consider the whole function and trying to differentiate and see if we make dy dx the subject and compare it with this, it will equal or not. So we have x cubed minus cy squared. We can ignore the x equals 0, so that x is ignored. Let's differentiate through. We're getting 3x squared minus 2cy dy dx equals 0. We're going to have 2cy dy dx equals negative 3x squared. So our dy dx will be 3x squared on 2cy. The negative will come and that will cancel out. But you can see there's a c here. Let's find that c by making the c subject from the original question. So making c the subject, our cy squared is equal to negative s cubed, and with that our c will be x cubed on y squared. So let's put c equals s cubed on y squared into our dy dx equals 3x squared on 2cy. So when that is done, our dy dx this equals 3x squared on 2, the c is now s cubed on y squared y. So this will cancel 1, and with that we are going to get 3x squared on 2s cubed on y. And now when we simplify, we are getting dy dx as 3y on 2x, and that's our equation 2. So you can see clearly that when we compare these two from the derivative, we have dy dx equals 3x on 2x. The same thing from here, when we simplify after differentiation, we have dy dx equals 3y on 2x. So when you substitute this one from the function into this side, it will be the same. Hence, this function is a solution to the differential equation. Therefore, s cubed minus cy squared at x is equal to 0 is a solution to the differential equation 3y dx equals 2x dy. Thank you very much for watching. Goodbye.